talking more about triangles today. We're going to be talking about triangles with specific characteristics, and those triangles we can label a certain way. The two that we're going to focus on are isosceles and equilateral, equilateral. People pronounce them different ways, but they mean the same thing. See if I can get this board on. Okay. Notice your assignment is on ALEKS. AWS means it's an ALEKS assignment. We're going to do A today, B tomorrow, so we won't have a new lesson tomorrow. We've got 2 more sections of notes, and then we'll start reviewing on purpose again, okay, after today. So this one and 2 more days. All right, so we're going to be talking about these 3 types of triangles: scalene triangle, isosceles triangle, and equilateral triangle. Everybody look at this first triangle. What do you notice about the markings on that first triangle? So they're all congruent. So on the sides, one side has 1 dash, another one has 2 dashes, and another one has 3 dashes. So which one of the sides are congruent to the other one? None of the sides are congruent, right? So let's look at the angles. One angle has 1 arc, one angle has 2 arcs, and the third angle has 3 arcs. So which of those angles are congruent? Are there any congruent? They're not, right? And that is a scalene triangle. A scalene triangle, for our purposes, is kind of worthless. It doesn't give us any information, right? But by definition, a scalene triangle, let's see if I can grab this thing. A scalene triangle has no congruent sides, no congruent angles, and no lines of symmetry. So we should know what a scalene triangle is, but scalene triangles aren't going to help us find the measure of a missing angle, or the measure of a missing angle, or the measure of a missing side. That's what we're going to use the special features of an isosceles triangle and the special features of an equilateral triangle for. So basically, the scaling offers no help. Okay? As far as lines of symmetry, I know we talked about lines of symmetry, I think, early on in triangles. I have a rectangular piece of paper here. I'm going to remind you what lines of symmetry are. If I fold this piece of paper in half, this rectangle in half, you'll notice a vertical line down the center, fold it in half. Everything matches up perfectly, right? Lines up perfectly because this side of the paper is exactly the same side as that. It's congruent, right? I can also fold it horizontally, right? And now you'll see that both sides are congruent. When I split it in half, they match up perfectly, right? So that's 2 lines of symmetry for this rectangle, right? This paper, also, we could fold it other ways, but there's no other way to fold it where those parts are congruent across that line, right? So our folds are like our lines of symmetry, right? So that would not be a line of symmetry because they don't match up, right? So no matter which way you would fold this triangle, they're never going to match up. It's going to look like that, right? Okay. So an isosceles triangle. So look at the marks on the isosceles triangle. What do you notice about the marks on the isosceles triangle? Are there any congruent parts? There are. Tell me one pair of congruent parts. Vivian? There's 2 angles that are congruent. Yeah, so there's the 2 angles that have 1 arc, right? So their mark's congruent. Right here and here. And are there any more congruent parts? We just said the angles. These 2 angles are congruent. Are these 2 angles congruent to this angle? We don't know that they are, right? They're not seeing that they are. Are there any other congruent parts, Elizabeth? Yeah, what are they? The sides with 1 dash, right? So, by definition, an isosceles triangle is going to have at least 2 congruent sides, and the sides opposite, the angles opposite those sides are always congruent. So if this side, the angle opposite from it is here. This side, the angle opposite from it is here. So if a triangle has two or more congruent sides, the angles opposite are always congruent. Okay? And it's going to have one, if there's only two sides congruent, it's going to have one line of symmetry. Now there's parts of this isosceles triangle that we need to be able to label. So the first thing I'm going to uncover is what is the base of this isosceles triangle. So the base is a side, just like when you use to define the area of a figure, base and height. So the base is this side, where the angles, those angles that are across from the congruent sides are. Those angles are called base angles. The sides that are congruent, they're not isosceles triangle, those are called legs. And that last angle up top, that's not one of the angles on the base, is the vertex angle. Oh, where did it go? Huh. Oh, I covered it up. So that's the vertex. I think maybe it's called the vertex point. The vertex is close enough, right? Okay, so anytime you have two or more sides congruent in a triangle, this is super important. Anytime that happens, the angles that are opposite of that side have to have the same measure. So if I know this is 40, now I know this one is 40, right? Let's look at, and by the same token, if we know both of these angles are congruent, guess what we know? We know the sides across from those angles are congruent. Okay, so it works both ways. Does that make sense, Morgan? Does that make sense, Myron? Okay. What do you notice about this triangle? All three angles have one arc. All three sides have one dash. So all sides are congruent to all sides. All angles are congruent to all angles. So all the sides are congruent. All the angles are congruent. And something important you need to know is that all equilateral triangles are also isosceles triangles. Because remember we said at least two sides congruent here. So all isosceles triangles are not equilateral, but all equilateral triangles are also isosceles. But you need to know that for today's homework because you're going to be checking all that apply. So if it's an equilateral triangle, then it's also going to be an isosceles triangle. Equilateral triangle is especially informative. Okay. So do you guys remember how many degrees are in every triangle? Charles? 180 exactly, right? Can't be any less, can't be any more. So if you did not remember that, even if you did remember, I can talk about it. Triangles have exactly 180 degrees. So there are 180 degrees. So if you add up all three angles, 180 degrees. In a triangle. And we're talking about the interior angles. Later on, we'll be talking about this thing called exterior angles. But for now, we need to know that when you add up all three angles, they have to equal 180 degrees, or it would not be a triangle. Okay? Do you with me? So if we know that there's 180 degrees in this triangle, as there are in all others, and we know that all three angles are equal, we actually know the measure of these angles. This is the only one that we would know that for. So if they're total 180 and all three have the same measure, what is going to be the measure of each angle? good. 60. It's going to be 180 divided by 3, right? So if they tell you that the triangle is equilateral, we already know that every angle is a 60-degree angle. My board is quite persnickety today. So 180 divided by 3. So we know that each angle would measure 60 degrees. Okay. So what's important to us is that we remember these relationships between the congruent sides, congruent angles, because we're going to be using these to find some missing measures of angles and these triangles and missing side lengths. First thing we're going to do, this is basically an example from your homework. We are going to look at triangle A. What kind of triangle is triangle A? Is it a scalene, an isosceles, or an equilateral? And we're going to check all that apply. Yes, very good. It's going to be an isosceles with 2 sides are congruent and 3 sides are congruent. That makes it equilateral, right? So I forgot to check the isosceles here. I need to check that. So you're going to put, check both of those. What kind of triangle is triangle B? Scalene, right? So if this is 30 degrees and this is 60 degrees, all 3 angles have a different measure. That means all 3 sides would have to have a different length. So it's going to be scalene. 3 different length sides. What kind of triangle is this one going to be? Scalene. Yep. So scalene can only be scalene. And 2 congruent angles here. So this is 45, this is 45, and what does that square mean? Yes, it's isosceles. 2 congruent angles means, remember, it means the sides across from that are going to be congruent. Right? So if there's 2 congruent angles, those would become the base angle, and these sides that are across from it are the legs. Okay, so it's an isosceles triangle. Is it also an equilateral triangle? No. All right, any questions on that? Okie dokie. So for each part below, use a figure to fill in the blank. If necessary, you may learn what the markings on a figure indicate. I surely hope that we know that by now. All right, what kind of triangle is in example 5? It is an isosceles. We have these 2 angles marked, sides marked congruent with 1 dash. So what does that tell us? So, and we know that one of the angles in that triangle is 110, right? The question asks us to find the measure of angle F. So we want to know, what is that angle? Total 180 degrees. Anybody have an idea how we would find the measure of angle F? Elizabeth? Perfect. So we know that this angle and this angle have to be congruent. So Elizabeth says, take that 110, that first angle, and subtract it from 180. And now that's 70 degrees. It has to be split evenly because they have the same measure. So now 70 divided by 2, I think I already have that written over here, and that would give us a measure of 35 degrees for angle F, and for that matter, angle D, right? So it's 35 degrees. Now, what kind of triangle is in example 6 here? It's all 3 angles. So equilateral, lateral means sides. If you're a person who works out, your lats are your muscles along your sides, right? So equa, basically from the root word equal, right? So equa or equilateral, equal sides. So they don't show us the sides here, but we have to know now that we learned about equilateral triangles, if any 2 sides are congruent, or angles or sides are congruent, the third side as well, that all the angles across from those have to be congruent. So while we don't know the side lengths of these 2, we know that they have to be congruent because it makes all of these base angles, right? So if this side is 3, this side also has to be 3. So the sides across from all of the angles would have to be congruent. Kind of, sort of. My arrow's in the wrong spot, but you get the gist, right? So having the 3 angles congruent tells us that the 3 sides have to be congruent. And if you think about that, it makes sense, right? If you've got a different angle here, then some of the sides would not reach or would be too long or whatever. So a triangle has to meet up exactly at those points. All right, so the measure of AB is 3. Remember, this is the measure of segment AB. That's how we read it if there's not a line across the top. We say that is the measure of segment AB, and that would be 3. So far, so good? Anybody have any questions? Because if all 3 angles are congruent, now we know all 3 sides are congruent, right? So if there were just two angles congruent, we would know that the opposite sides have to be congruent. But we know that all 3 are congruent, so that means all 3 sides also have to be congruent. Yes, good question. Okay, so this is how we're going to use some of these new things we've learned about the features of an isosceles and an equilateral triangle. We want to find what does the angle in this triangle measure, right? They only give us, out of all 6, they give us 2 angle measures. 75-degree angle in this triangle, and then they tell us that this angle down here in the bottom that overlaps both triangles, all together, those 2 angles are 90 degrees. Does that make sense? So we're going to learn some things we know. So for me, I'm looking at, okay, I'm going to start marking my diagrams. These 2 sides are congruent, so I don't know what's going to help me with what right now, but I know that means that the angles across from that are going to be congruent, right? So I know, that angle is going to be congruent. Because those 2 angles are going to be congruent because they are across from the congruent sides, right? I look over here and I say, oh, they share this side, but this side and this side are also congruent. So now I have another isosceles triangle. Does that make sense, Carmen? Okay. So I know that that angle and that angle, the angles across from those triangles have to be congruent. Let's mark them congruent. I didn't mark that one. Let's mark that one and that one, and that one, and that one. So then I start with this one here. I know that every triangle has 180 degrees. So that's always going to be my starting point. So in here, in this triangle, there's 180 degrees. Now, we just said that this angle and this angle are congruent, right? So what's that other angle going to measure? It's going to measure the same thing. My board is not right. Oh, there you go. Heavens to Murgatroyd Batman. All right, does that make sense to everyone? All right, so we know that together these 2 are 90. If I know what this angle is, now I can find the measure of this angle, right? For my purposes, I just start figuring out all the stuff I can figure out and then see how it helps me answer the question, right? The question is, what is x? So I'm making my way around to x. So what is this angle going to measure? If this angle and this angle measure 75, sorry? It would be 30. How'd you get 30, Ashlyn? I added 75 to each other, which is 150, and I can subtract it from it. Perfect. So, and that is the strategy for all the things. You're either going to add them all up or add 2 up and subtract. There's kind of the same thing, right? So she added 75 and 75 together, got 150. She subtracted 150 from 180. She's exactly right. That angle in between here is 30 degrees. Now, this 30 degrees plus something is 90 degrees. So now we can find out what the measure of this angle is by just subtracting it from 90, right? So 90 minus 30 is going to give us that this angle is 60 degrees, and it makes sense. 60 plus 30 is 90. That's what that little square means. All right, so that's not the angle I want. That's not congruent to the angle I want. But Elizabeth showed us how to find the answer earlier. If we know this is 60, we take that and subtract it from 180. These have to have the same measure. So if you have two numbers that have to have the same measure, you just divide that by 2, right? So it's going to be, use this mouse when I can. So it's 180 minus 60, which means that these two together are 120. So it means that these angles are 60, which means now that while this bigger bottom triangle is an isosceles triangle, now we know it's actually also an equilateral triangle, right? If this is 60 and this is 60, now we know that that third side also has to be congruent. But really all they ask us is, what is x? And x is 60 degrees. Does that make sense, Jatavia? Are you writing it down? Okay. Does that make sense, Maya? Okay. So we're going to be doing kind of the same thing with example 8. They give us one angle measure. Here they don't give us a right angle or anything, but we can still find the measure of x kind of by working our way around to it. I've got a number here, so I'm going to start in this triangle. Can anybody tell me, which angle can I find the measure of first? This top one or this one? Which one do you think we should find first? King? This one or this one? Top or bottom? Okay, well tell me how to find the bottom.
Oh, we already have my number.
Okay, tell me how to find the top.
It's a triangle, so it's 180.
Start with 180. It's always a good place to start. Get that in your mind. Okay, 180. What do these marks mean, King? Those sides are congruent. If two sides are congruent in a triangle, what kind of triangle is it? What kind of triangle is that then? There's two sides. Nope. Scaling is that no sides are congruent. Stay with me. Isosceles. Isosceles. So in an isosceles triangle, what is it? It says at least two angles are congruent. Read what else it says in your notes. On your notes, King. Under isosceles, it says at least two angles congruent. What's right below that?
Angles, opposite angles, congruent sides.
So the angles opposite of the congruent sides are congruent. So that angle and that angle have to be congruent. So if this one's 29, what's this one going to measure, King? Yes. Because they have to be congruent. So how are we going to find the measure of that angle? Devanshi?
180 minus 29 minus 29.
So 29 and 29 is 58. So 180 minus 58 is 122. So we still don't know what x is, but we're making our way there, right? So another, what kind of triangle is this one, Adine? Two congruent sides, what do we call it? Good, the isosceles. So that means that the angles across from those are both congruent, right? So now this angle and this angle are congruent. So if we know what this angle is, we can find both. If we know that this angle is, we can find both because they have to be the same measure, right? Okay, I'll tell you we can't find that one. But we can find this one. This angle and this angle are what kind of angle pair that we've learned about? What kind of angle pair are those? Helen, what do you think?
Linear pairs.
That is a linear pair. What do we know about a linear pair? When you add those two angles together, they're supplementary. That means they equal 180. The sum of those two angles is 180. So if I know this is 122, how can I find that one? Just subtract it from 180, right? 180 is our magic number. 180 minus 122 is 58. So now we know this angle is 58, which means, because these are the base angles, I'm going to mark these two arcs, can't mark them the same. This angle is congruent to this angle, so that makes this angle 58. Morgan, can we find x now? Yep. How will we do it? What are we going to start with? Always starting with 180. Okay? This angle plus this angle plus this angle equals 180. So how can I find this angle? 58 times 2 is 116, I believe. So we're going to subtract 116 from 180, and that would be 64. So now we know that this x, the measure of this angle, is 64 degrees. Does that make sense, Tori? Okay. All right. Any questions? No, one more? Okay. While I'm thinking about it, I am not going to make you turn in work for these. My heart wants you to turn in work for it, especially for the last one we're going to do. The last one you're going to write an equation and solve, right? But you can thank Mr. Rayleigh and Mr. Huntley if you walk by them. Mr. Root said, the only reason we don't turn in our work this time is because y'all are making your kids turn it in, okay? But that doesn't mean you shouldn't be writing down stuff. It just means you don't have to turn it in, okay? So you have to write down this stuff? Probably not. If you understand it, then you can just do it on your calculator. I'm not that worried about that. But this next one, you need to be able to write an equation and solve it. And you need to do that on paper, right? So this example says, suppose the triangle HIJ is isosceles with base HI. So let's go ahead and write these there. So this side is the base. We see they've marked the congruent sides of our base triangle. That means that, of our isosceles triangle. That means that these are the base angles, right? If this is the base, the angle on either end of the base are the base angles, and we know in an isosceles triangle, those are congruent. They're also across from those congruent sides. So we should know that. So, that being said, if we want to find the degree of each measure in the triangle, we don't have any number except for the magic number 180, right? And we know that all three angles together equal 180. We know that the measure of angle H can be written algebraically as 4 times x plus 31, and the measure of angle I can be written as 2 times x sine over x plus 41. And we know that those are congruent, hint, hint. So we should be able to write an equation. When we're writing an equation, when we use congruent, we want to use an equal sign, right? So what would our equation be to solve for x? If we know what x is, we can plug in here to the 4x plus 31 and find the measure of angle h. We can plug in to 2x plus 41 and find the measure of I. Once we have those two angles, we can find the third one, right? So what would the equation be, Marina, do you think? 4x plus 31 equals 2x. Perfect. Perfect. So this is one that I would definitely expect you to have some pencil and paper out, or a whiteboard and marker, or if you're at home, writing in the dirt, something, right? 4 times x plus 31 equals 2 times x plus 41. I've got x's on both sides. I'm going to take 2x from both sides. And I have on the left side 2x plus 31. And I have 41 remaining on the right side. I'm going to take 31 from both sides. I'm going to take a shortcut there. 31 minus 31 is 0. 41 minus 31 is 10. Divide both sides by 2. And now I know X is 5. Remember, they didn't ask me for X, but I need X. Right, so for H, I'm going to take that 5 and replace the X with 5. So instead of 4 times X, it's 4 times 5. Plus 31. And for I, 2 times 5 plus 41. So I do the math, 20 plus 31 is 51. Well, these should be congruent, right? So if H is 51, then I should be 51 too, and we can double check that. 2 times 5 is 10, plus 41 is 51. So we know I is 51 degrees. We know H is 51 degrees. So how are we going to find out what the measure of angle J is? What are we going to add together? Okay, so the measure of angle J is 102. No. You're on the right track, though. Right. This plus this equals 180. So 51 plus 51 is 102. Take our magic number, 180 minus 102, and now we know the measure of angle J is 78. If you add all three of those together, you would get 180 degrees. Any questions? Okay. So remember, I'm not grading all the notes, but I am going to spot check and grade some notes, so you should still be turning your notes in every time. The assignment is posted. Go ahead and scan and submit it. And we still have 5, 10, 15 minutes to work on your assignment. There's only 10 questions. You should be able to knock out a good portion of it. Okay? You don't have to submit anything to Canvas. Just submit it on Alex.